Okay, ji, welcome back to today's lecture and let's start then. Bismillahirrahmanirrahim. Um, I believe we have left it somewhere here yesterday, okay? So we were discussing and talking about, let's have a brief uh, overview about what we have already discussed. So the mixed design procedure starts with the required material information, and by that we mean that the sieve analysis of both the fine and the coarse aggregates must be done with. We have to do the unit weight, the specific gravity, and absorption capacities of both the aggregates as well. And apart from these, we have to have some information regarding the cement, like what type of cement do we need to utilize, what type of weather conditions are there, like whether we need air entrained concrete or not, or uh, uh, like if we need a specific type of cement to be used. So we are going to define all of these in the required material information. Then afterwards, we did the choice of slump. So it was concluded that the general slump value ranges from 1 to 3 inches. Okay? But still, in certain conditions, you are also allowed to have a 4 inches slump, but that is not highly recommended. Then later on, we went out for the definition of maximum aggregate size, and we have had three limitations about that size. And generally, we have a size of 0.75 to 1 inches of aggregates that are available in the market. Then afterwards, we went for the estimation of mixing of water content, like what would be the water content, and considering the 0.75 inches of maximum aggregate size and a slump of 1 to 2 inches, we got the water content to be 315 for non-air entrant concrete. Okay? So this was one of the conclusions. Then later on, uh, we saw a bit of a few charts, a few graphs, which were depicting the maximum aggregate size with respect to the water requirement. So we have concluded over here that if the aggregates are smaller in size, the surface area increases, and for the lubrication of that surface area, we need a lot more of water content. So this was the conclusion in both the air entrant and the non-air entrant. But overall, the air entrant concrete needs a lot less water as compared to that of the non-air entrant. So let's go ahead with the step number 5 of ACI mix design. The step number 5 is water cement ratio. Now we have to define, or this would be defined by the table that is being given in the next slide. So let's read it out first. This component is governed by strength and durability requirements. Strength is basically uh, the strength that you need to the concrete to have. ठीक है? So without strength versus water cement ratio data for certain material, a conservative estimate can be made for the accepted 28-day compressive strength from table 3. So the underlying the next the table on the next slide is going to be the table number 3. So it gives us a depictive or predictive water cement ratio for the required strength. Durability. If there are severe exposure conditions, such as freezing and thawing exposure to seawater or sulfates, the water cement ratio requirement may have to be adjusted. But we are not discussing this durability issue right now because the concrete that we are exposed to, the weather that we are exposed to, it would be taken care of with the help of air entrainment. Okay? So let's go to the table. If this is a relationship between water cement ratio and compressive strength of concrete. So if we need a 28 days compressive strength of let's suppose 5000 psi, then we need a water cement ratio to be 0.48 for non-air entrant, and for the air entrant it must be equal to zero point 0.4. You getting the idea? Okay, so this water cement ratio is now in previously we defined the amount of water that we need. Now we have defined the water to cement ratio. So obviously from both of these we can find out the amount of cement. So next is to calculate the contents of cement. Once the water content and the water to cement ratio is determined, the amount of cement per unit volume of the concrete is found by dividing the estimated water content by the water to cement ratio. So it is simple. Previously, in the previous table, in the table number one, we defined the content of water that we need, and in the previous table, that is table number three, we defined the water content, water to cement ratio. So from there, we can find out the weight of cement. However, a minimum cement content is required for, so it is obvious, for the weight of cement must be appropriate, must not be lesser. Now, the next step is the estimation of coarse aggregate. The five main constituent materials that are there in the concrete, that is the fine aggregate, the coarse aggregate, the water, the cement, what else? There are four only. Okay? So these four must be calculated like weight wise or volume wise so that we are able to utilize them. So the next phase is the estimation of coarse aggregate. What would be the weight of coarse aggregate that is going to be needed for this concrete mix? The percent of coarse aggregate to concrete for a given maximum size and fineness modulus is given by table number 4. So the coming table would be the one defining the coarse aggregate content. The value from the table multiplied by the dry rodded unit uh, weight of coarse aggregate required per cubic feet of the concrete. Okay? So this the value from the table would be then multiplied by the dry or rodded unit weight. Like if the aggregate is being dried and then it is rodded to fill up a specific volume, and then the unit weight of that volume has been taken out, so that unit weight would be multiplied by the value from this table. To convert from oven dry to saturated surface dry, SSD weight multiplied by 1 plus absorption capacity. So ये जो चीज़ है, this last sentence, this would be elaborated in the coming slides, so this might not be evident right now, and we would have to look into a few details for this. So this table number 4 gives what? Volume of dry rodded coarse aggregate per unit volume of the concrete for different coarse aggregates and fineness modulus of fine aggregate. Let me give you an overview of what we are talking about. Let's suppose we are having a cylinder. My drawing might not be okay, but I will try to come up with something good. Okay. If we are filling it with concrete, the whole of the voids would be filled up by the concrete, right? Right. If it is only filled by the coarse aggregate and there is nothing to go into the gaps between those coarse aggregates, what would happen? The coarse aggregates would come in contact with each other, and we are rodding these coarse aggregates to fill in the gaps appropriately, like they are being compacted as well by rodding method. Okay? But there are some open voids and holes within this space, like the, let me get another color, like the spaces in there, these spaces are going to be there. Obviously they are going to be there. So the volume of dry rodded coarse aggregate, now this is the dry rodded coarse aggregate per or divided by the unit volume of concrete. So the unit volume of concrete would be, the normal volume of concrete for different coarse aggregates and fineness modulus of fine aggregates. So let's suppose the aggregate that we utilize is having, the fine aggregate that we utilize is having fineness modulus of 2.7, and the maximum aggregate size is 0.75. Let's suppose this is the one. So what would be the ratio over here? the ratio would be what? 0.63. It means that 63% of the total concrete's volume would be filled by this coarse aggregate. You getting the idea? 63% of the whole of this volume would be filled in by the coarse aggregate. If we increase the size of coarse aggregate, for example, you see 1 inch, 1.5 inch, 2 inches, 3 inches, and 6 inches. If we increase the size, you see about 84 or 85% of the volume of concrete is being filled in by this coarse aggregate. چې څوک په پوه نه شو نو let me که پوه نه شوې نو تاسو تپوسو کې زه بیا آنسر ورکوم په دې آیډیا باندې
سر
سوچ
جی دا ټیبل لا تفصیل کړ
اچھا دا ټیبل چې کوم دی دې کې درې سیزونه دي number 1 is the finest modulus of fine aggregate. You must remember that this is for fine aggregate, this finest modulus, okay? This is for fine aggregate. The maximum aggregate size, this is for coarse aggregate. Okay, ji? This is for coarse aggregate, this is for fine aggregate, and what you would get out of it? You would get a ratio of coarse aggregate that would occupy the concrete volume. You see, the value that you get is the coarse aggregate will occupy what? This much volume. It would occupy 0.63 percent of the whole volume. This is the value that you are getting from there. उसमें पूछ भी लग सा गोरे दा पूरा सिलेंडर द कंक्रीट न डक कम का ना द कंक्रीट नजर डक कम द दे के हो नोर्स सवी कोर्स एग्रीगेट भी फाइन एग्रीगेट भी सीमेंट भी ओबवी और सनसा एयर वार्ड्स भी ठीक दा यो सिलेंडर दे न डक शवे दे हो कचरे ज दा सिलेंडर सिर्फ और सिर्फ कोर्स एग्रीगेट न डकोम नो कोर्स एग्रीगेट ब दे सिलेंडर के सोना वॉल्यूम ब फिल की नो هغه به 63% والیوم به پکې فیل کی یا 0.63 به پکې کورس اگریګیټ وي د نه علاوه پکې شګي د نه علاوه پکې سیمنٹ او اوبه به پکې نور چې کم 37% پاتې کیږي اوس په ورځې ده
जी सर यस
Yes, sir. Push, sir.
Huh, good. So this is a predictive method. It is not 100% accurate. I'm repeating it again because according to the recommendation, the ACI recommendation, it would give you a trial mix. Okay? That trial mix would be tested after 26 or 28 days or whatever the days it needs. And after those tests, only then you would be able to find out whether the trial mix is okay or not. So this trial mix is being made by this predictive method. Now, the value that I'm getting from here, that is, for example, 0.63 value, this is then multiplied by 27, the value from table 4 over here, it is then multiplied by 27. Now 27 is what? 27 is the unit conversion of feet to cubic yard, like 1 yard cube YDQ is equal to 27 cubic feet. That's a unit conversion there. You get the idea? So basically this is 0.63. We are supposedly saying that this is 0.63 cubic yard. So let's multiply it with 27 to get a cubic yard value. Okay? So cubic yard divided by like it is trying to convert the units over here. Then what happens? The oven dry weight of the coarse aggregate. This is the final result that you are getting from here. This result multiplied by dry rodded unit weight. Now this dry rodded unit weight must be found out prior to the start of this mixed design method. چې شروع کې مونږ دا وی کنه چې we should have some values that must be found out before doing this mixed design. نو هغه کې یو دا dry rodded unit weight of coarse aggregate هم دی دا هم تاسو find کوئ به Now our value multiplied by this value is going to give you a value that is pound per cubic yard. Yeah, density with the velocity. Now, volume of dry rotted coarse aggregates per unit volume of concrete for different coarse aggregates and fineness moduli of the fine aggregates. So like the watoma. اوس هماغه ټیبل چې کوم بره دی هغې نه ډفرنٹ ویلیوز دي پکې اچولې دي نو هغه ټیبل نه تاسو ته څه اندازه وشوه نامینل میکسیمم اګریګیټ سایز نو چې اګریګیټ سایز تاسو زیاتوئ دا وګورئ چې څونه د اګریګیټ سایز زیاتیږي نو هغه عمره بلک والیوم فریکشن اف کورس اګریګیټ یعنی کې کورس اګریګیټ کوانټیټي پکې څونه زیاتیږي نو که چېرې دا میکسیمم اګریګیټ سایز نیم انچي وي یا 0.5 انچي وي نو په هغه ټایم کې کورس اګریګیټ به تقریبا 45% به په کانکریټ کې او کچره دکا کورس اګریګیټ سایز موږ 3 انچز ته ورسو نو دا غي پرسنټیج ان والیوم به تقریبا 80% په کانکریټ کې this is simple mathematics ठीक है depending on the fineness modulus of the fine aggregate the values also changes right ठीक है now the next thing उस पूरे मुंगा the weight of water وکته weight of cement وباسل water cement ratio وباسل او coarse aggregate weight هم مونږ راوباسل final پاتې شو fine aggregate content the fine aggregate content چې کوم دی هغه هم مونږ راوستې شو څنګه راوباسو مونږ سره total volume چې کوم دی هغه مونږ څه ویلي دي مونږ سره total volume یا خو 1 cubic yard دی یا 27 cubic feet دی مونږ دا وې کنه we considered it to be 27 cubic feet یا 1 cubic yard نو اوس مونږه هغه total نه د هر یو راوباسو like the total if the total is 27 cubic feet 27 minus the volume of water the volume of coarse aggregate the volume of cement so we would get the final result to be the volume of fine aggregate ठीक है కదా दगा शर्त मुंगा राविस्ते शो so estimation of fine aggregate content there are two standard methods to establish the fine aggregate contents the mass method and the volume method we will use the volume method no us बात वास्तव में volume method ना आसांतिया भी लग ठीक है this method is preferred method as it is somewhat more exact procedure the volume of fine aggregates is found by subtracting the volume of cement water air and coarse aggregate from the total concrete volume this is the whole idea now fine aggregate content बताओ څنګه راوباسي نو هغه د لپاره water تاسو سره د غشته volume راوستل غواړي نو تاسو water weight تاسو سره شته دی divide کې 62.4 سره نو pound per cubic feet به divide شي pound به کټ شي cubic feet کې volume به پاتې شي دغه شرط cement unit weight تاسو پته دا 3.15 دی ٹھیک ده coarse aggregate specific gravity تاسو رشته دی هغه به تاسو کنورټ کې دغه تا unit weight تا unit weight of water سره multiply کې تاسو سره volume راوځي دغه شانتي coarse aggregate او air د لپاره هم تاسو چې کله volume راوباسئ air د لپاره specifically داسې چل کیږي چې the content of air is defined depending on the air entrainment or non-air entrainment ٹھیک ده که تاسو air entrained concrete تاسو پکار وي نو تاسو پکې air entraining admixture به اچوئ but at the same time you would also define چې تاسو څونه extremity پکار ده 2% پکار دی 3% پکار دی 5-6% پورې 6% maximum air entrainment تاسو کولی شئ په concrete کې so که تاسو ډېر extreme cold weathers کې if you are producing the concrete then you must make sure that the air content has been increased Therefore, the fine aggregate must occupy a volume of 27 cubic feet minus this whole volume would be the volume of fine aggregate. ठीक है ना दा कोई इजी खबर है ओस द volume of fine aggregate ना taso weight travistal body. Now multiply by specific gravity of fine aggregate multiply by unit weight of water is equal to fine aggregate weight in pounds, which is saturated surface dry. Now उसदा मुंगा लग साथ के दा saturated surface dry oven dry दा बस सुनो लग साथ की गुरु. Give me a moment. Sorry. अच्छा जी. So now what are these oven dry, surface saturated dry? So let's discuss all of these. And by discussing, we mean that we go to step number nine over here. This step number 9 is going to be the factor for the adjustment of moisture content in the aggregates. There is going to be some moisture that the aggregate can absorb, and there could be some moisture that the aggregate has on its surface. Basically, we need the moisture to be there so that the concrete gets lubricated, the aggregates get lubricated, and they start workability, like they start flowing. So the surface must be wet enough for the concrete to start working, you see. So for that reason, you need to have the concrete wet, the aggregates in wet condition. Now, there are four conditions that are discussed over here. The first one is oven dry, in which if there are some internal holes or there are some portions within the aggregates that can possibly get filled with water, those are also being dried out with the help of oven drying method, you see. So oven drying method would enable to remove almost all the water from the aggregate. In the air dried condition, the aggregate is dry from the surface, but there is some moisture within the holes of the aggregate. Like there are some minor holes and minute holes within the aggregate that are still beholding some of the water. There is another condition that is known as saturated surface dry, in which there is some water within the holes, but at the same time, if there are some gaps or some portions on the surface of aggregate, those are also filled in with water. So this is some condition that is it is an ideal condition to have, like the whole of the aggregate is saturated from within, and the only water that you need is to lubricate its surface. The next condition is wet condition, in which the whole of the surface is also wet, and at the same time all the internal holes and uh, minor portions within the aggregate are also filled with water. So this is the fully saturated condition. This is saturated surface dry condition. This is air dry condition, and this is oven dry. Now, ideally, if we have aggregate under this saturated surface dry condition, we are okay with it. Like we need this ideal condition. If this condition is of such an state, like if we are adding some additional water in the concrete, it would help in the lubrication of these aggregates and the concrete would start working. But if the condition is either wet or if either it is dry condition, either it is air dry or oven dry, what would happen is if you are adding water into the concrete, either it would go in to fill in the gaps in there, the gaps in the aggregates, or either it would get excess of water on the surface, and probably the aggregate could start bleeding as well. So this is an important phase to have either this saturated surface dry condition, or otherwise if we have these conditions, so we need to adjust the water content in aggregate, in the concrete, sorry. You getting the idea? समझ आ रही है इसकी? आवाज आ रही है मेरी?
जी सर।
समझ आ रही है ना
Yes,
इस
sir.
बार? The ideal condition is going
Yes,
to
sir.
be saturated surface dry, but if you are having an aggregate which is wet condition, or either in dry condition, so we have to adjust the water content according to that condition as well. क्या message आया है? Yes sir, okay, thank you. Now, the absorption capacity of aggregate is up till this saturated surface dry. If it is oven dry, it would need water to go into its holes. If even it is air dried, it would need water. If it is saturated surface dry, over here the absorption capacity is exhausted. After this, there is some surface moisture on the aggregate. Okay. So in other words, this absorption capacity can be named as AC, and the surface moisture can be named as SM. You see? The water content of the concrete will be affected by the moisture content of the aggregate. So we have already discussed this notion. Let's move ahead. The water content of the concrete will be affected. Okay, the same statement. So basically, the moisture content would be equal to what? Aggregate capacity plus surface moisture. You see, moisture content MC of the concrete of the aggregate is equal to aggregate capacity plus surface moisture. Now, adjustment for moisture in the aggregate. We need to adjust the moisture content for the aggregate in the stockpile. जहाँ से आप पत्थर उठाओगे, the source that you are going to use for that source would be tested for its condition, and if we see that the aggregate is in oven dried, or like not obviously oven dried, it would be or either air dried, or either it is wet condition, or it is saturated surface condition. So considering that fact, we are going to adjust the weight of aggregate. The weight of aggregate from the stockpile is equal to the weight of this weight from the stockpile is equal to weight oven dry multiplied by 1 plus moisture content. You see, so multiply by 1, so this would be oven dried weight plus weight of oven dried multiplied by moisture content. So you are adding in some moisture content into the aggregate because it is from the stockpile. So the stockpile aggregate is going to have some moisture content in it. The change in the weight of water due to the moisture of the aggregate from the stockpile would be delta weight in water. So now, because of this moisture content, or because of this surface moisture, we need to change the weight of water. Sorry, we need to change the weight of water. So the change in the weight of water is equal to weight of oven dried multiplied by surface moisture. Weight of oven dried aggregate multiplied by surface moisture. So let me give you another example, another explanation. Up till this condition, this is the neutral state condition. So we need the aggregate to have this much water in it, but we don't need it to be wet condition, to have wet condition. The additional water that it is having, the surface moisture, we need to subtract this from the total water content that we are going to add. So this is calculated over here. The total change in water, or the minus water weight in water that you are going to do, is equal to weight of oven dried aggregate multiplied by surface moisture. You get the idea or not?
Yes, sir.
Yes, sir.
समझ लग रही है ना? So the adjusted weight of water is simply equal to weight of water minus the delta weight of water. The delta weight of water is equal to this point. So come sona pake izafi ubadi aga mungatina minus cover water. We need to subtract that so that the concrete is not having excess water in it because of the stockpile sourcing. अच्छा जी. Now the next phase is trial batching. Now trial batching was daga de sample jodol di sample daga kawal di daga slump test kawal di age na pas age cylinders jodawal di and sample daga kar de. Using the proportions developed in the preceding steps, mix a trial batch of concrete using only as much water as is needed to reach the desired slump. उस चिकलामुंगा दे के वाटर कंटेंट डिफाइन करना नमुंगा चरता कंक्रीट जोड़ोल शोरोकू नमुंगा आगमरा उबा इस्तेमालो ची सोना द वर्केबिलिटी द पारा पकार दे even kamunga delta for example 0.48 water content munga define karo. Let's go back to the slide that where we have defined that. Even if we have defined it to be 0.48 water to cement ratio and the concrete is workable enough at 0.45, so we don't need to go up to 0.4 at 8 at any condition. Lesser water means higher strength and we already know that. So using lesser water is a good thing, it is not a bad thing. You just need the concrete to be workable enough. The next thing is, if you are going for the concrete workability and you want it to be workable enough, so you cannot then exceed this 0.48 value. You cannot go to 0.50 just because you want the concrete to be workable enough. You cannot do that. You cannot exceed this target water to cement ratio or the water content. Okay, all right. The next thing is trial batching. The fresh concrete should be tested for slump, unit weight, yield, air content, and its tendencies to segregate, bleeding, and finishing characteristics. Also, hardened samples should be tested for compressive and flexural strengths. Okay, so the next phases are all about testing of the concrete for their air content, for the unit weight, slump कितना है, ठीक है, उसकी compressive flexible strength कितनी है, segregation bleeding तो नहीं हो रही, finishing उसकी अच्छी हो पा रही है, इतना कम पानी तो नहीं है कि वो finishing उसकी नहीं हो पा रही, so on and so forth. Okay, now let's go ahead for an example so that we are capable to do all of these exercises on our own. Okay. Concrete is required for an exterior column located above ground. So if it is located above ground, so you can utilize normal concrete. If it were underneath the ground, you could have needed sulfate resisting cement because there might be uh, some interacting water or underground water that could react with concrete. Okay, so it is above ground where substantial freezing and thawing may occur. By substantial, it means that a significant amount of freezing and thawing would occur. It means we need concrete that is air entrained, and there are extreme conditions of air entrainment that we need, like 6%, the maximum value. The 28 days compressive strength should be 5,000 psi. The slump should be between 1 and 2 inches. The slump should not exceed 2 inches, you know. So 50 millimeter is the maximum value for slump. And the maximum aggregate size should not exceed 3 by 4 inches. So almost all of the things are being given. The next properties that we need from the aggregates and from the cement and both the aggregates are also given. Cement is type 1, that is normal Portland cement. The specific gravity for cement is 3.15. The coarse aggregate bulk specific gravity is 2.70. Its absorption capacity is 1%. Now, by this absorption capacity, you know that the absorption capacity plus surface moisture, you've already got the idea. Okay, na? So this is the absorption capacity. It can only absorb 1% of the weight of 1% by weight of its uh, aggregate weight. Okay. Dry rodded unit weight is 100 pound per cubic feet. The surface moisture is 0%. So there is no surface moisture on this coarse aggregate, which is a good thing. It means that it is saturated surface dry condition. Now fine aggregate, the bulk specific gravity is 2.65. The absorption capacity is 1.3%. The fineness modulus is 2.70 and surface moisture is 3%. Now over here, if you can see, the fine aggregate conditions are a bit wet because there is some 3% surface moisture on the fine aggregate as compared to the absorption capacity to be 1.3%. Okay. So इसके लिए हमें adjustment करनी पड़ेगी. We shall see कि इसके adjustments कैसे होती हैं. Required material information. So that is already given. जो step number 1 था उसमें तमाम information जो कि हमें निकालनी थी वो हमें given है. Choice of slump. So slump is also given. The step number 2 is it is 1 to 2 inches. Step number 3, maximum aggregate size. This is also given 3 by 4 inches. Step number 4 is the estimation of mixing water and air content. So 0.75 is the maximum aggregate size and 1 to 2 inches slump is the limit. So your water content is going to be 280 and pound per cubic yard, by the way. The unit over here is pound per cubic yard or density. And the air content is going to be extreme, which is 6% in this condition. ठीक है. फिर उसके बाद क्या है? Step number 5 is water to cement ratio. From the table, the estimated required water cement ratio to give a 28-day strength of 5,000 psi. So for 5,000 psi and for a concrete of air entrained, you are getting a value of 0.40. What else? Now we need to calculate the weight of cement that we need. So the weight of cement is equal to 280, which is the weight of water, divided by 0.4, which is the water cement ratio, which gives you weight to be 700 pound per cubic yard. Now estimation of coarse aggregate content. For the fine aggregate fineness modulus, that was given to be 2.7.